Hello everyone, welcome back to my YouTube channel. What is regression in machine learning? So regression learning is supervised learning where the response variable is continuous. These are the assumption of the linear regression. So we must be sure that this is verified before deploying our model or before saying that this is the first we can even build the model and then at the end trying to explain the outputs using this relation. So then the first thing we should check is the linearity. There is a linear relations between the dependent variable x and the dependent variables. We should make sure. Then how to check it if we have relation, uh, linear relationship between the independent variable x and the dependent variable y. The first thing we should do is to do the scatter to check the scatter plot of the residual. We can check it like plotting the scatter plot of residual versus fitted value, and then this should show a no systematic pattern. The second assumption is independence of errors. Definitions of this mean that the residual errors should be independent of each others. So meaning that there is no correlation. Then how to check it? We can check it like by using the Dashbin-Washington test. This mainly used for time series data. We can ensure that there is no pattern that exists in residual over time. Then the third assumptions is the homoscedasticity. So what does it mean? It means that the variance of the residual should be constant across all levels of the independent variables. How to check it? We can just check it by plotting the residual versus the fitted value. So then how to, after plotting it, how to check, how to find out the conclusions. We just need to see if there should be no founded funnel shaped pattern. We have seen it in the last video. You can just go back and see how we did the interpretation of the plots and of this. So then the normality residual, which the residual should be normally distributed. So then, or we can say that the residual should follow a normal distribution. You should know what is the normal distributions. How can we check if something is following some distribution is normally following the normal distributions. Then we can check it by using the QQ plot. You have seen it in the last video. We can just go back and see it. And then, or we can just try to perform a statistical test like Shapiro-Wilk or Kolmogorov-Smirnov test. So that with those tests, instead of using the QQ plot, we can just use the Shapiro-Wilk, and then at the end of the day, we just find out the conclusions, calling the p-value of the test, so that we can conclude. If you want me to explain more about these topics, you can just put them in the comment, and then I will come back on each of them and try to explain them more. So then the fifth assumption is the multicollinearity. There should not be multicollinearity. So the independent variables should not be highly correlated with each other. So how to check it if my independent variables are not correlated, are not highly correlated with each other? Then I can just, the first things is just to compute the variance inflammation factor. The abbreviation is sometimes VIF. So then a VIF, after computing this variance information factor, if I say that the VIF is greater than 5 or 10, it means that we have a multicollinearity. Then, or I can just plot the matrix of covariance and see the covariance or the relation between the pairwise of each variables. You see, so then we can see this variable with all others one in and so far and so on. We see how they are really correlated. And then the sixth one maybe is the issue of outlier or high leverage points. What does this mean? It means that the outlier and influential points should not excessively impact the regression results. How to check them? Like use cook distance or leverage statistic to identify influential points. Check residual plot for extreme values. So then check the residual plots and then we see the SM values how they are distributed.